Okay, let's move into section 6.8. We will see some formulas, some rational formulas, and we're going to be solving for different variables. Basically what that means is if I gave you a formula, distance equals rate times time, which is actually what we're going to see in the next section, instead of having the formula solved for distance, we might have to solve for the rate or the time. So if we solve for t is the distance over the rate, and then rate is the distance over the time. So we're basically going to be doing the same thing today, but with rational formulas. So we're going to use rational expressions, as we just did. Another area this may pertain to is a common SAT question, a type of SAT question. So I threw one of these on here in warm-up number 2. This is an SAT type question where you might have to solve for some type of variable in terms of another variable, similar to what we're going to be doing today. And number 1 warm-up is what we just did, solving rational equations. So go ahead, pause the video, work out these warm-ups, and check back to see how you did. Alrighty, so for number 1, you should get 3/8 for x after you multiply it through by the LCD of 6. And number 2, well, since both 2r and 6t are equal to 5s, you can set them equal to each other. And we are asked to solve for r in terms of t. So I need to get r by itself. I undo this multiplication with division, divide both sides by 2. You get r is 3t. So letter C would be your answer. Okay, we just have a couple examples to get through and then the checkpoints. Like I said, you're going to be given a bunch of formulas and you need to solve for a certain variable. Okay, so this first example here, V equals pi r squared h, this actually represents this is the formula for the volume of a cylinder with a radius r and a height h. You don't really need to know what these formulas represent. I'm just more concerned with you being able to do the math and solve for one of the variables. So here we're supposed to solve for h. So the way we're going to do this, we just need to undo our order of operations in reverse. Here I'm going to undo my multiplication. That's the only really operation I need to undo. So I undo multiplication with division. I divide both sides by pi r squared. Here the pi r squareds cancel, and I'm just left with h equals v over pi r squared. So that really was a basic one, kind of like the distance equals rate times time. It wasn't even a rational formula because we had no denominators. But when you look over at letter B, this is a rational formula because we have a rational expression over here. We have variables in the denominator. So what we do, a good rule of thumb for this is to multiply both sides by the LCD, which is exactly what we did in the last section. Okay, so our LCD is just going to be 1 minus r. So if I multiplied through by 1 minus r, on the left side, I would just be left with s times 1 minus r. And on the right side, the 1 minus r's would cancel. So I'd be left with a times 1 minus r to the n. And we were asked to solve for a, so I need to get a by itself, and we have some multiplication here. So I can undo that multiplication with division again. So I would just divide both sides by 1 minus r to the n. Here the 1 minus r to the n's would cancel. I'd just be left with a, which is what I was looking for, and I am done. So you want to make sure that whatever your answer is here, it cannot contain the variable that I'm trying to solve for. So even though I have a by itself here, if I had an a over here as well, that's no good. Okay, but I don't, so I'm in good shape here. If you wanted to distribute the s, you could, but not necessary. You could just leave it factored. You would look to try to cancel some factors, but we don't really have any factors that could cancel, so we would just leave it like that. Okay, go ahead and look at these 2 checkpoints. Go ahead and see what you can do. In letter A, try to solve for g, and in letter B, try to solve for y sub 1. And this is just a head start into the best way to probably tackle these problems. Like I said, the good rule of thumb, you don't have to always do it this way, but the good rule of thumb is to multiply through by the LCD. So that's my first step. And go ahead and pause again and take it from here. Okay, number 1, once I multiply through by the LCD of 2g, I'm left with 2g equals v squared. I want to get g by itself, so I undo this multiplication by dividing both sides by 2d. Same idea over here. Once I multiply through by the LCD of y sub 1, y sub 2, these denominators cancel out. I want to solve for y sub 1, so I undo this multiplication with division of x sub 2, and this is what I'd be left with. All right, last two, a bit more challenging. Remember, for letter C, multiply through by the LCD for a good start. Your LCD is big R, R sub 1, R sub 2, R sub 3. And my first step for letter D, it looks, I'm not even sure what this formula is for, but it is very complex looking, so I would clean this up and make it look a little bit more like a rational expression, like this. Okay, so it would look something like that. And if you want to take it from here, the way I taught you, you don't have to do it this way, but I taught you to multiply through by the LCD, which in this case is 4CL squared. So go ahead, try it that way, see what happens, and check back to see how you did. I want to stop halfway through this letter C to point out to you that since I'm solving for R sub 1, once I get once I multiply through by the LCD, I see there are 3 terms that contain R sub 1. So what I want to do from here is I want to get all 3 terms containing R sub 1 on one side, factor out that common factor of R sub 1, and then divide through. So go ahead and pause and see if you can finish that up. And finally, for letter C, I can undo this multiplication and solve for R sub 1 by dividing both sides by this R sub 2, R sub 3 minus big R, R sub 3 minus big R, R sub 3. And I think I have a typo here. I shouldn't have 2 R sub 3s. Let me go through and fix that. There we go. And our final answer would be, this will be your final answer for R sub 1. Letter C. Letter D, after I multiply through by the LCD, this is what I would get. I'm trying to solve for R squared, not R, just R squared. So I need to get this R squared by itself. So I'm going to undo this other term first. I'm going to get rid of the other term, then I'll worry about undoing this multiplication. So I'm going to undo the order of operations in reverse. I'm going to subtract 2L pi from both sides. And then I can divide, undo the multiplication with division, divide both sides by negative C. And I don't want to leave a negative C like that. So basically what I can do is I can multiply top and bottom by a negative 1. And that's not changing the value of what I have here. This would become a positive C. And this here, remember our little trick, we would just flip these terms around. So my final answer for R squared would be this here. If I wanted to, up top I could factor out a GCF of 2L, but it's not necessary because nothing's going to cancel down here. But if this term had a C in it, then I would definitely want to do that because I would have a C here, a C here. I could factor out a C and then cancel something out, but not necessary to factor if you don't want. And just to show you another way that you could get to this answer, instead of following our general rule of thumb, if you prefer this way, of not multiplying through by the LCD, you could first subtract this term, this pi over 2LC, and this is what you'd be left with. And then just to get R squared by itself, all I have to do is multiply through by a negative 4L squared and distribute that to all terms. This is what you would get. You have some now you have some more simplifying to do, so it is a little bit more work for you here in the end. For instance, L squared over L, one of the L's cancel. 4 over 2 reduces to just 2 over 1. So this 2 cancels, this 4 becomes a 2. And I need my denominator C, I need to combine these to be a single rational expression. So over here I'd multiply top and bottom by C, and then I can combine them and I would just get the same thing that we got before. Maybe a little more work, but some of you may prefer it. Just giving you another option to what works best for you. So go ahead and try this last question. It's a closing question. It's a little easier than the ones that we just did. And solve for H in terms of L and V. So maybe you didn't do it this way, but my first step was to get rid of the fractions, just because I always think it makes it easier if you can get rid of any denominator. So I multiplied through by that LCD, which is 3, was left with 3v equals L squared h. Then to undo this multiplication, I used division of the L squared, and you're left with h equals 3v over L squared. Okay, your homework is 12 problems, page 278. And I give you some hints here for numbers 20 and 22. The formula is not given to you. So you actually need to kind of read the examples 1 and 2 on pages 276 and 277 and understand what formulas you're going to use and what the variables in each of those formulas represent, because you're going to have to plug numbers in for those variables. So good luck.